Welcome back. In this video, we are going to talk about Avogadro's law, which explains how the amount of gas particles affects the space they take up. And we'll define a specific set of conditions called STP that allow us to easily do some calculations. Avogadro's law is very intuitive. It basically states that the volume of a gas is proportional to the number of moles of that gas. If you have a flexible container like that shown here in the simulation, and you remove gas particles, the volume has to go down to accommodate them. And likewise, if you add gas to the volume, then it's going to increase. Because the volume of a gas changes so easily with temperature and pressure, scientists establish a baseline called STP, or standard temperature and pressure. Standard temperature and pressure is defined as the freezing point of water, which is 0 degrees Celsius, and approximately atmospheric pressure, which is 1 atmosphere. But since it's kind of fluctuates a little bit, scientists have decided to use the value of 1 atmosphere. Here's the magic number for this section. At STP, 1 mole of any ideal gas occupies 22.4 liters of space. To visualize how much that is, think of stacking up about 11 2-liter soda bottles into a shopping cart. That total volume is what 1 mole of a gas is going to look like at STP. That applies to any gas like oxygen or nitrogen or helium or CO2 or any other gas you can imagine. This leads to an interesting realization. Even though a mole of oxygen gas is much heavier, weighing 32 grams, than a mole of helium, which is only 4 grams, they both take up the exact same volume of 22.4 liters at STP. And this is because the gas particles themselves are so tiny compared to the vast empty space between them. Let's take a look at this practice problem here. How many liters? Okay, so we want to first write down that 1 mole of any gas is 22.4 liters. That's basically Avogadro's law, and it's valid at STP. Then what we want to do is we want to write down 2.45 moles of CO2 times, and then use this equivalency as, once again, drag 1 mole onto the bottom so it cancels. And that leaves 22.4 liters up on top. And so we can see how the moles here cancels. And that's going to be our answer. So on our calculator, you're going to take 2.5, multiply by 22.4, and I get 56 liters here on my calculator. Let's do another problem. How many moles is 20 grams of helium at STP? So 20 grams of helium is how many grams? How many liters? Okay. So first of all, we know that 1 mole is equal to 20.18 grams. And that's for neon from the periodic table. It's a monoatomic gas. We also know that 1 mole of neon, any gas, is equal to 22.4 liters. That is Avogadro's law. So now we have to convert things. We start off with 20.0 grams of neon, and we want to multiply and put a fraction bar, and then we want to grab the two components here. 20.180 grams on the bottom will allow the grams to cancel. And up on top, we have 1 mole of neon. So we're using the periodic table here. And what you can do is grab your calculator, type in 20.0, and divide by 20.180, and see what your calculator gives you. I get 0.991 mole neon. That's step one. We've used that conversion factor. Now the second step is to take the 0.991 moles of neon that we just calculated, set up a multiplication with a fraction bar, and I'm switching to blue here so you can kind of follow along. We want 1 mole of neon to be on the bottom, and then we're going to have 22.4 liters up on top. So that's great. The moles now cancels. And on your calculator, you can grab and enter 0.991 times 22.4. And let's see here. I get 22.2 liters. So that's going to be how you do this problem.